Comparing key features of linear functions. So we spent a decent amount of time of identifying key features, but one of the benchmarks is to be able to compare key features, kind of saying like which one has a bigger y-intercept, a larger x-intercept, and so on and so forth. So number one says compare the functions f of x and g of x. It says which function has a greater y-intercept, okay? So with the graphs, the y-intercept is very easy to identify, right? Because for f of x, the y-intercept looks to be at -2, right? For f of x, maybe I'll just write that. F of x, the y-intercept seems to be at -2, while g of x, the y-intercept, now I don't know exactly what that is, but I can kind of identify it as -4.5 about. So the question is which one has the greater y-intercept? So which number is larger, -2 or -4.5? Well, -2 is greater than -4.5, right? So it's even higher. You can even notice it as it being higher. It's larger. -2 is greater than -4.5. -4.5 is less. So f of x would be the answer here. F of x has a greater y-intercept. So now let's compare the x-intercepts. So for f of x, the x-intercept seems to be around here. Now, I don't know exactly what that is. It looks more than 0.5. I don't know. Maybe it's I don't know. Let's just estimate that as 0.7 or something. So it's about 0.7. And then for g of x, it looks to be at 3. So obviously, g of x has a bigger x-intercept. So these are just estimating, and I'm writing them out, kind of. You don't need to do that. But g of x definitely has a greater x-intercept. C says which function has the greater rate of change? And rate of change is just the slope. It's another way of saying the slope. So f of x slope, let's do that first. Let's do f of x. So maybe here and here, the slope is up 3 over 1. So 3 divided by 1 is just 3. So the slope of f of x is 3. And the slope of g of x is, let me pick a couple points here. Here, here. That would be 3 over 2, which is like 1.5. 3 divided by 2 is 1.5. So the slope is 1.5. So f of x has the greater rate of change. And you can just, if you just look at it, you can tell that as well because it's steeper, right? F of x is a steeper line. It's got a greater rate of change. So that's one way you can see that as well. So that's how you can compare with graphs, So I'll let you do 2. Let me show you 3 where we have an equation and a table. We have h of x and r of x. It says which function has the greater y-intercept? Now remember, y-intercept is when x equals 0. Keep that in mind. But for h of x, it's actually written in the equation. It's 8 because it's in slope-intercept form. So I know the y-intercept is 8 for h of x. Now for r of x, this might be a little more challenging because remember, the y-intercept is when x equals 0. But there isn't a spot for 0. But I know 0 would be between -1 and 1. So I know this y-intercept is going to be between -8 and -12. And it's actually exactly going to be at -10 because it would split them. So r of x, the y-intercept is at -10. So which function has the greater y-intercept? Clearly h of x. 8 is larger than -10. Now, how about the x-intercept? Remember, the x-intercept is when y is 0. So for the equation h of x, we can't just see it in the equation. So I'm going to have to do some math. So for the x-intercept, for h of x, I'm going to plug in 0 for y. So I'll have 0 equals -4x plus 8. Subtract 8 from both sides. Divide by -4. It's 2. And this is for h of x. It's at 2. That's the x-intercept is 2. Now for r of x, you can see it. It's here. Remember, the x-intercept is when y is 0. Y is 0 right here. So the x-intercept is 5. So for r of x, the x-intercept is 5. So which one has the greatest? R of x. Which has the greater rate of change? Remember, rate of change is just slope. Let me erase some of this because it's getting a little overwhelming. Rate of change is just your slope. And for h of x, the rate of change is -4 because it's in slope-intercept form. So I already know what that is. For the table, I'm going to find the slope. I'm just going to do rise over run. So it looks like it's going +4 while this is going +2. And that's a consistent pattern here. So the slope, 4 divided by 2, whoops, why did I write +4 there? 4 divided by 2 is just 2. So the slope of r of x is 2. So which one's greater, -4 or 2? Well, 2 is greater than -4. D says, as x increases, y increases for which function? So this one we might have to kind of draw a visual. Well, for h of x, if I were to graph this, it's got a negative slope. So it starts up at 8 and it's got a negative slope. It's going to look like this. So as x increases, as we go up this way, y actually decreases. So I know it's not h of x. So let me just confirm that it's r of x. So if I were to draw r of x, at -1, it's at -12, so somewhere down here. At 1, it's at -8, so maybe here. At 3, it's at -4, so maybe here. At 5, it's at 0. At 7, it's at 4. So I know that it's going to look something like that. So as x increases, as we go out this way, y is increasing. And you can tell that within the table of values as well. As x increases, these numbers are increasing. So are these numbers. These are increasing as well. So that's the fact. R of x. As x increases, y increases. I'll let you do 4. Number 5, kind of tough because now we got 3 functions. We got an equation, have a table, have a graph. It says which has the greatest y-intercept. So let's list them all out. Let me list out, so let's do f of x. Okay, so f of x, the y-intercept in slope-intercept form is -20. F of x would be at -20. On g of x, that -10. Remember, the y-intercept is when x equals 0. And then h of x would be, -12. So which one is the greatest? Well, the greatest out of those numbers, they're all in the negatives. -20 is less than all those. -12 would be the second smallest. -10 is the greatest. So g of x has the greatest y-intercept. Okay, let me erase some of this. Which function has the greatest x-intercept? So for f of x, we can't just see it from the equation. we want to see where is it going to cross the x-axis. Well, remember the x-intercept, when it crosses the x-axis, the y is 0. So for f of x, if I plugged in 0 for y and solved, add 20 to both sides, divide by 5, I get 4. So for f of x, it's 4. For g of x, this is also difficult because remember we got to look where y is 0. Well, I don't see in these y values a 0, but I can estimate where it would be. That 0 should be somewhere between the -2 and 6, because at 1 it's at -2, and then at 2 it's at +6. So it has crossed the x-axis somewhere. So I know that for g of x, it's between, I'm just going to write between 1 and 2. It's between 1 and 2 because I know the y value is going to hit 0 between the x values of 1 and 2. Now, h of x, I can clearly see the x-intercept. It's at 6. Okay, so let's compare now. Which function has the greatest x-intercept? Well, f of x is at 4. G of x is between 1 and 2. And h of x is at 6. 6 is the greatest x-intercept. Lastly, which function has the greatest slope? F of x is written in slope-intercept form. I know the slope is 5. For g of x, I'm going to have to do rise over run. So it looks like this is going +8, while this is going +1, and that's consistent for the entire table. So for g of x, the slope is 8. Now for h of x, I'm going to do rise over run as well. I'm going to pick a couple points. Maybe I'll pick this, and then, quite frankly, I could pick a lot of these. I'll just pick this, I guess. It's going up. Now it's going by 2s here. It's going up 4, and then the run is 2. So 4 divided by 2 is 2. So for h of x, the slope is 2. So the greatest slope, g of x. You do 6? I'll do 7. The King and Morris families are handing out pieces of candy for Halloween. The amount of candy the King family has left can be modeled by the function c of t equals -8t plus 550. Let me highlight that. Where c of t represents the pieces of candy remaining and t represents the time in minutes since trick-or-treating started. The Morris's family candy remaining is modeled by the graph below. So I'm going to kind of label these down here. This is going to be time. And this is going to be up here on candy. Okay. So it says which family started with more candy. So let's first talk about the King family. I'm going to write King. So the King family, their candy remaining is modeled by what I highlighted in pink. And if we think about what the y-intercept means, this 550, that's how much candy they started with. So the King family started with 550. And then this is, so let me highlight King family in pink. And then this graph, this is the Morris family. And the Morris family looks like they started with, if I look at the y-intercept, that's about, what would you say that's at? So 450 and 500 in between those two. That would be at 475 about. So which family started with more candy? We'd go with the King family because they started with by 50. B says which family is handing out candy out at a faster rate? Well, the King family, if we look at what we have highlighted up here, it's in slope-intercept form, and we know the slope is -8, right? So that means they're handing out 8 pieces of candy per minute. So King is handing out 8 pieces per minute. That's the slope. But if we look at Morris, then we got to see how fast they're handing them out. Now, it kind of gave us 2 points here, so we can find that slope with those 2 points. So it goes from 355 to 175. So if I subtract those, let me just kind of create a triangle. 355 to 175, if I subtract those, 355 minus 175. And we could use the slope formula if we want, but this is 180. They're giving away 180 pieces of candy. And then from 20 to 50, 50 minus 20 is 30. Over 30 minutes. So for Morris, it's 180 over 30 minutes would be 180 divided by 30 is 6. So they're giving out 6 pieces per minute. So who's handing out candy at a faster rate? The King family. They're handing out 8 pieces per minute. While the Morris family, if we find the slope, they're just handing out 6 pieces per minute. So C says, assuming they continue to pass candy out at a constant rate, which family will run out of candy first? So if they run out of candy, that means their candy is 0. So if we're using this equation for the King family, let me re-highlight this. If we're using this equation for the King family, when they run out, this candy will be 0. So I'm going to say for King, I'm going to say 0 equals -8t plus 550. And then solve it for t. Subtract 550 from both sides. Divide by -8. I got not a very nice number, but 68.75. So the King family will run out of candy after 68.75 minutes. Now let's think about the Morris family. The Morris family we can actually see from the graph. When they run out of candy, they have 0 candy. It's about here. And I would estimate that at about 79 minutes maybe. So the Morris runs out around 79 minutes. So which family will run out of candy first is the question asking. This again is the King family. Okay. I'll let you do the last word problem.